Hello friends, today we are going to discuss about the topic cement. So first we will have a small understanding of the basic concepts associated with the cement, and at the end of this discussion we have certain questions based on this discussion and we will try to solve it out after completing this. So let's move on to the discussion. Here we are going to focus on these three main topics: ingredients of cement, manufacturing of cement, and the box compounds. The first one is ingredients of cement. So the most chief ingredient in cement is lime, and it constitutes 60 to 67%, and it is the one that provides a binding property to the cement, and excessive use of lime can cause unsoundness in cement. Unsoundness means it can undergo larger expansion even after setting. That means change in volume can happen. This change in volume can adversely cause this structure by affecting the durability of the structure. So next to lime we have silica. Silica consists of 17 to 25%, and it is responsible for providing the strength of cement. And excessive use of this silica can also can cause detrimental effect on the cement, and it can cause reduction in strength also. And next to silica we have alumina. Alumina consists of 3 to 6%, and it helps in the initial setting or quick setting of cement. So after alumina we have iron oxide. Iron oxide is comparatively lesser than alumina, and it contains 3 to 4% in cement, and it imparts the hardness and color to the cement. So next to iron oxide we have 2% magnesium oxide in it. So magnesium oxide also has a certain impact in strength. It provides the grayish green color to the cement. And next to magnesium oxide we have sulfur. Sulfur will be normally 1 to 1.5% present in the cement. So sulfur also provides soundness to the cement. So next to sulfur we have gypsum. So gypsum will be added during the manufacturing process of the cement. While grinding that clinker, we will discuss it in the later slides. While grinding the clinker we will add gypsum. So gypsum will be added to control the setting of cement. Normally 3 to 4% of gypsum will be added to the cement. And next we have alkalis. Alkalis will be normally 1 to 1.2%. It will be very less in composition, and excess can cause effervescence. So next we will move on to the manufacturing process of cement. So the process of manufacturing of cement, it consists of grinding the raw materials and then mixing those raw materials. The raw materials will be calcareous raw materials and argillaceous raw materials. Calcareous raw materials are limestone and chalk, and this argillaceous raw materials will be clay and shale. So these raw materials will be ground and then mixed in certain proportions depending upon their purity and composition, and after mixing them properly in the desired proportion, this compositions will be burned in a kiln at a temperature of 1300 to 1500 degrees Celsius, and then at that temperature this mixture will form some nodular shaped clinker. This clinker will be cooled and then it is ground to fine powder with addition of about 3 to 5% of gypsum, and the final product thus formed will be the ordinary Portland cement, and this product will be used for manufacturing of the Portland cement. So mainly two processes known as wet and dry process, depending upon whether the mixing and grinding of the raw materials is done in wet or dry condition. Okay, so we will look these two processes separately. The first one will be wet process. In this wet process we will collect the calcareous and argillaceous material separately. So this calcareous materials will be crushed and stored in silos, and this argillaceous material will be washed and stored in basin. So this is the main difference between wet process and dry process. So in wet process there will be involvement of water. So in this argillaceous material we have added water to it to store it in the basin. Then these two calcareous and argillaceous materials will be fed onto the channel where it is mixed and ground, and then a slurry will be formed. So to that slurry we will add the ingredients to it, and then we will store it in the storage tank. This is the initial stage of manufacturing of OPC or the cement in wet process. Next we will move on to the dry process. In dry process, the difference is that here there is no involvement of water. Here the calcareous as well as the argillaceous materials, these two are the raw materials that I have already told in the previous slide. So this calcareous and argillaceous material will be crushed. Both of them will be crushed, and then it is again made finer by using turn mill. So this crushed calcareous and argillaceous material will be fed together, and it is mixed in proper proportion by adding ingredients to it, and then it will be stored in a storage tank. So this is the initial stage of manufacturing of the cement using dry process. So next we will move on to the final stage. After this storage, what will happen? We can have a look at it. So the final stage will be from the storage tank where all this mixture has been kept and stored. We will supply this mixture to the rotary kiln. So this rotary kiln, in that rotary kiln, the formation of clinker will take place. This slurry or this mixture will be heated to 1300 to 1500 degrees Celsius, and small modular shaped clinkers will be formed. So this clinkers will be again cooled, and then it will be grinded in a ball mill. And while grinding in that ball mill, to that clinker we will add gypsum. This gypsum will be added to control the setting of the cement and to extend the initial setting time. Otherwise the flat set of cement can take place, and the cement will be set within no time. So after that, after the mixing of this gypsum, it will be stored, and then it will be packed in baggages. So this is the final stage of manufacturing of cement. Okay, so next we will move on to the third topic, box compounds. So this box compounds, what are these box compounds? When water is added to the cement, there will be some exothermic reactions, like heat energy will be liberated. So while adding water to it, apart from this liberation of heat energy, there will be generation of other chemicals also, and these complex chemical compounds are termed as box compounds. So we will have a look at it one by one. The first one is C3S. C3S is tricalcium silicate. It is also called elite, and its composition is 45 to 65%. And this tricalcium silicate is responsible for providing the early strength of the cement or the structure, and it can have a liberation of 120 calorie per gram of heat. So the next one is C2S, dicalcium silicate. So this dicalcium silicate is also known as belite, and it has a composition of 15 to 35%, and it is responsible for the later strength. That means the progressive strength, and this strength will acquire after 1 week of placement, and the heat can be evolved. 62 calories per gram of heat can be evolved from it after this reaction. The next one is tricalcium aluminate, C3A. It is also called celite, CELITE, and its constituent is 8 to 12%. And here there is nothing to do with the strength. There is no contribution of strength actually, and it can happen within 24 hours. And the heat energy here is comparatively more, that is 207 calories per gram heat will be liberated once this compound has been formed. Then we have phyllite, FELITE. Phyllite has 10 to 12% composition. Here also there is no strength contribution, and it can occur within 24 hours with a liberation of 120 calories per gram heat. So these are the ingredients, these are some of the ingredients, and then manufacturing, and then box compounds that we have discussed. And based on this discussion, we will move on to the question part. So the first question will be, the density of the cement is taken to be. Here they have given 4 options. What they have asked for the density of the cement. It is a standard value, and it will be taken as 1440 kilogram per meter cube. So here the option C is the right choice. Okay. So moving on to the next question. Weight of 1 bag of cement is. This is also a standard question. The weight of 1 bag of cement is always taken as 50 kilogram. So option B is the right choice. So moving on to the third question, most important constituent of cements are, options are C3A and C2S, C3S and C3A, third one is C3S and C2S, and fourth one is C3A and C4AF. C3A is tricalcium aluminate and C2S is dicalcium silicate. So C3S and C2S is the answer. Option C will be the answer because these two are responsible for the strength that I have discussed in the box compound session. C3S and C2S together they constitute around 60 to 70% of the strength, that too earlier as well as the later strength. So answer is option C. So moving on to the next topic, the calcine product in cement production is known as, the calcine product. This one we have discussed in the manufacturing of cement. The answer will be the clinker. Clinkers will be formed when this slurry has been heated in the rotary kiln. Clinkers will be formed. Okay, so that calcined product will be clinker. Option D is the answer. So next one is the volume of one bag of cement. Volume of one bag of cement. As I have discussed in the previous slide, the density of cement is 1440 kilogram per meter cube, isn't it? So the volume of one bag of cement is having 0.035 meter cube. So how we will arrive in that value? We know that the volume of the weight of one bag is 50 kilogram and the density of the cement is 1440 kilogram per meter cube. That means for one bag the density will be 1 by 1440. For 50 bag the volume will be 1 by 1440 into 50. So the answer will be 0.035 meter cube. Okay. So moving on to the next question, the ingredient that imparts color and hardness to the cement. The ingredient that impart the color and hardness to the cement is iron oxide. That too we have discussed in the ingredients of cement section. Okay. So next question, the ingredients added in the manufacturing process to control the setting time of the cement. So the answer is the ingredient added in the manufacturing process to control the setting time. This one also we have discussed in the manufacturing topic. The answer is gypsum. Gypsum will be added to prevent the flash set, to control the setting of the cement. That means by extending the initial setting time. So gypsum will be added, 3 to 4% will be added to it. Okay. So the next question is, the setting action of cement is accelerated by adding. This is also a standard question and the answer will be calcium chloride. So calcium chloride will be acting as an accelerator for setting action. So calcium chloride will be the answer. Okay. Next, gypsum is added in the manufacture of Portland cement. A, while mixing the raw materials. B, during burning in rotary kiln. C, during the grinding of clinker. And D, none of the above. This one too we have discussed in the manufacturing process, and this gypsum will be added to the grinding. After the grinding of the clinker, to that one we will add directly this gypsum. So the option C will be the answer. So the next question is, the ultimate strength to cement is provided by. We can directly mark either tricalcium or dicalcium silicate. So tricalcium is responsible for the early strength and dicalcium silicate is responsible for the ultimate strength. So the correct option will be option B. So with this we will wind up the session. If you have any queries regarding the this class, you can mention in the chat box or comment section. Okay. So thank you very much for your time. Thank you.